Hello dear students, today we will have our second lecture about Module 3 and today we are going to talk about electrical circuits. As you can remember, last time we discussed with you effect of a current and today we are going to continue this topic. First of all guys, electrical currents and electrical circuits, they have very similar description. Electrical circuits, according to Thomas Edison, this is all you need to be an inventor, as a good imagination and a pile of junk. Exactly, this is our Ohm's law. I hope that you remember how we can use it about Ohm's law formula. Here we have I equal V and R. I, it's our current amperes or amps. V, it's our voltage or volts. And R, this is our resistance or ohms. And also in the screen you can see the picture of George Simon Ohm, the inventor of this. How you should be thinking about electric circuits? Guys, right now you can stop this video and think about this a little bit. Exactly, voltage is a force that pushes the current through the circuit. In this picture it would be equal to gravity. Also here this an example of this. How do you should be thinking about electric circuit? Yeah, of course, this is resistance. Resistance, this is a friction that impedes flow of current through the circuit. Rocks in the river, this is the example of this. How do you should be thinking about electric circuits? Think about this. Yeah, exactly, current. The actual substance that is flowing through the wires of the circuit, they are electrons. And here guys also you can see the examples of it. Guys, can you think also about would this work in this picture? What about this? Would this work? What about this? Would this work? And the central concept closed circuit, will this work? What do you think about this? Okay guys, I hope that you gave the right answers. Now let's talk about circuit diagram. Scientists usually draw electric circuits using symbols or pictures like this and like this. This is our cell, this is our lamp, switch and wires. Guys, if we're talking about simple circuits, let's discover this. Series circuit, all in a row, one pass for electricity, one light goes out and the circuit is broken. And in the second picture we can see parallel circuit. Many paths of electricity, one light goes out and the others stay on. It's also really simple to understand how simple circuits work. If we're going to talk about series circuits, first of all they connect one bulb on the battery, then connect two bulbs and the battery form a series circuit, connect three bulbs and the battery to form a series circuit. Mark from 1 to 3 each diagram according to the brightness. Since the brightness of the bulb indicates how much current flowing in the circuit, write a statement which describes what happens to the current in a series circuit as you add more resistors to the circuit. Think about this, please. The right answers 1 and the second. Guys, let's talk about parallel circuit. Place two bulbs in the parallel. What do you notice about the brightness of the bulb? Add a third light bulb in the circuit. What do you notice about brightness of the bulb? Remove the middle bulb from the circuit. What happened? I think that you can imagine the result of these three equations. Let's talk about measuring current. Electric current is measured in ohms, or A, using an ammeter connected as series in the circuit. This is how we can draw an ammeter in our circuit. From the left side you can see series circuit, from the right side you can see parallel circuit. Measuring voltage. The electrical push which the cell gives to the current is called the voltage. I hope that you remember this definition from our previous modules. It is measured in volts, or V, on a voltmeter. This is how we can draw a voltmeter in a circuit. From the left side we have series circuit, from the right part we have parallel circuit. Also, here we can imagine a measure of a current and voltage across each circuit. Use Ohm's law to compute resistance. And also I can see that you will do it really correctly. This is our series circuit. Current is the same at all points in the circuit, and in our parallel circuit current is shared between the components, as you can see in the first and in the second picture. Fill in the missing ammeter readings. It's also really simple to understand. Here we have 4, in the second picture we have 3 and 1. Series circuits. Explain what happens to the current in a series circuit when there is a break in the circuit. And one more. Explain what happens to the voltage across each bulb as more bulbs are added to the circuit. I hope, guys, that everything was clear about today's lecture. And after this lecture you will have some tasks and they are optional to do. See you next time. I wish you good luck. Goodbye.